is sort of an overview of reciprocal functions and rational functions. There's two that are really related, but there are a few differences, right? How you're going to draw the function. So first, let's start off with the reciprocal functions, all right? The parent function, hopefully, as you remember, has this formula. Now remember that what I do is I always like to write the key points, all right, for anything that where I can actually write the parent function. All right, now I'm going to say those key points are -2, -1, 0, 1, and 2. Now on 0, if I were to plug in a 0, 1 over 0 is undefined. Okay, so this is undefined right here. If I were to plug in a 1, I would get a 1. If I plug in a 2 for x, I get a 1/2. Now this will give me a -1, and this is a -1/2. Okay, so essentially all the points that I have are the following. 1, 1, -1, -1, and let's see, 2.5, and we have this one as -2 and -1/2. Right now, that doesn't look like much, and it sure doesn't, right? So you do got to understand that, first of all, there is a vertical asymptote here, and the vertical asymptote is because you cannot divide by 0. So because you cannot divide by 0, that's where my vertical asymptote's at. So this is my vertical asymptote. And on my parent function, I also have a horizontal asymptote, and that one really comes more from the fact that as x gets bigger, you get closer and closer to y is equal to 0. So you get closer to 0, but you're never quite touch that asymptote, okay? So in general, I don't really need you to know that, but what I do need you to know is I need you to understand the basic shape of a reciprocal function, which looks like this. All right, as I mentioned before, my vertical asymptote is that x is equal to 0. My horizontal asymptote in this case is y is equal to 0. My domain is all real numbers except for x cannot be equal to 0. All right, so there's different ways to write that. Normally, I just write x is not equal to 0. For my range, y is not equal to 0. All right, so this is the standard form of those functions. All right, so if you remember, and again, I've done this before, but we remember if h is going to be the horizontal shift. Guys, no, get out of here. Sorry, that was my dog trying to jump on my lap. Right, where if it's plus h, that's actually going to move it to the left. So think about it, that's backwards, right? That's why I always tell you that your x lies. And your minus is actually going to shift this to the right. Okay, k is a vertical shift, where plus is going to move the parent function up, and the minus is going to move the parent function down. If a is negative, meaning this a right there, then the function is reflected across the x-axis. If the absolute value of a is greater than 1, then we have a vertical stretch. Oops. And if a is between 0 and 1, the absolute value of that, then you have vertical compression or shrink. Now, if you are looking at some formula like that, this is actually very easy. The vertical asymptote is always going to be x is equal to h, and the horizontal asymptote is always going to be y is equal to k. All right, and I'll show you what that means in just a second. So let's look at this first example. So on example number 1, right, first you got to realize that means to the left 1, and down 5. So we're going to basically rewrite our parent function, but now I'm going to move my vertical asymptote to 1 and my horizontal asymptote to 5. Okay. So this now is going to be my fake origin, right in between those that cross line. All right. So now I don't want to put a point there because if you look at the parent function, which is right here, and I'm going to use it, all right, the first point that I should have is 1, 1, and -1, -1. Now, this is not being reflected or anything like that. So the first points I'm going to have are here and here. And really, that's really all you need, guys, all right? You don't have to do anything more than that because after that, you're going to get a bunch of fractions. But you just got to know in general what is the shape of a reciprocal function. Okay. So that's that. So my vertical asymptote, right, just by looking at it, my vertical asymptote is going to be x is equal to -1. Now, how do I know that? Because this right here is going to be the opposite of whatever that number is, right? My horizontal asymptote is going to be y is equal to -5. And again, how do I know that? It's right there. So before I even draw the graph, I could actually do it like that, okay? My domain is going to be x cannot be equal to -1, and my range is going to be y cannot be equal to -5. All right. So that's that for example 1. All right. So let's look at example 2 and let's just talk about the transformations in it. First, you're going to move to the left 3. It's being reflected because that's a negative. And it's going to be stretched by a factor of 2. Okay. So let's first put our vertical and horizontal asymptote. My vertical asymptote now is going to be at -3. And notice that my horizontal asymptote, I never shifted this graph up or down, so it stays right in the middle, right? So my fake origin is right with the cross line, crosshairs, I should say, are located, which is right there. All right, now, for my parent function, y is equal to 1 over x, okay, I have the points that you have at the top, so you don't necessarily have to write them every time, but for this one, it might help you out just a little bit. Okay, now normally this is for the parent function. Okay, now stretch by a factor of 2 is going to make it where you multiply only the y coordinates by 2, or in this case, I'm going to do by -2 so I can take care of the reflection part too. All right, so this is going to be, that's going to be 1 here. That's going to be a +2. This is going to still be undefined. This is going to be a -2, and this is going to be a -1. Okay, so let's go off those points. The first point I should graph is 1, -2. So from my fake origin, which is right in the middle, that's the first point. And the next one we can graph is 2, -1, which is right there. Okay, and so the rest will look like this. So you don't have to graph too many points. A couple is fine. You just got to know generically what does this graph look like, all right? The other points are -1, 2. And then -2, 1. Okay, which means this part of the graph will look like this. Okay. All right, so my vertical asymptote would be x is equal to -3. Notice is the opposite. Let me not get too color crazy here. X is equal to -3. My horizontal asymptote is y is equal to 0. And if you know that, that basically gives you your domain because x cannot be equal to -3. And my range is going to be y cannot be equal to 0. Okay, so that's that. All right, let's go ahead and take a look at now rational functions. Now, look, the equation form for this one is different, all right, than a reciprocal. Now, I honestly don't care what you call it. Technically, even a reciprocal function is a rational function anyway. But the main difference is that when you have a rational function, you have a polynomial function divided by another polynomial function. I know that sounds exciting. Try to hold it. I know you're dying here. But anyways, so here's an example of that. Just look at example number 1, right? The top part is a function. The bottom part is a function, meaning the numerator is not just a number, okay? It's an actual function. So to figure out the x-intercepts, we always set the denominator equal to 0. And solve for x. I'll show an example of that in just a second. So vertical asymptotes. So you're going to set the denominator equal to 0. There's a little bit of a step you have to do that, which I will show you, right? So normally before you try to do any of this, you need to factor the numerator and denominator and see if anything will cancel. Oh, shoot. And I just realized up here on the x-intercepts, I meant to say the numerator, not the denominator. I'm so sorry. All right, so we're going to set the denominator equal to 0 and solve for x. Okay, now for the horizontal asymptotes, remember that this kind of looks complicated, but essentially we have Bobo, Botu, and Betsy. Bobo means bigger on bottom. So let's see, what do they call P here? Okay, but that's bigger on top. So this is... Okay, this right here would be Bobo, bigger on bottom, which means that my horizontal asymptote would be equal to 0. Okay, and then I do explain this in more detail in previous videos, so check that out when I talk about rational functions, which let me see if I can... I have... that would be in lesson 7. 8-7. So you should have just watched that lesson not too long ago. Okay, so Bobo is bigger on bottom, bigger on top. It's undefined, and what that means to you when it's undefined, that means that you don't have one. So you have no horizontal asymptote. Okay, and then finally, if the degrees are the same, then you have Betsy, the friendly asymptote cow, I guess. Where that would mean the coefficients means the ratio of the coefficients. So you find the leading coefficient of the top, which is P of x in this case, divided by the leading coefficient of the bottom, which in this case they call Q of x. And you know how I feel about the letter Q in math. It's very confusing. It looks like a number 9. But anyway. Now finally we talk about holes, all right, which is a break in the graph. And normally on a graphing calculator, they're basically impossible to detect. You can't really see them. But this is how you find them. You basically factor the denominator, which is, well, let me start with the numerator. The numerator, which is the top part of the graph. Can't spell numerator. And denominator. And cancel. And let's see. And then you're going to cancel common factors, I should say. If you do have that instance, you're going to have, you're going to set your canceled common factors equal to 0. And solve for x. Then you're going to substitute. Oh, man. You're going to substitute the x coordinate into the simplified function, and that's going to give you the y. And that seems like a lot. And I'll show you. It's not as bad as it seems when I actually have to write it down. Okay. Okay, so in example 1, right? First thing I want to do real fast just to make sure that I don't have any holes is I can factor the numerator and denominator. Now, nothing's going to cancel here, so I actually don't have a hole. So if nothing cancels, then don't worry about it. There's not going to be any holes, all right? Now, as far as the x-intercept, we're going to set the numerator, I keep saying that backwards, equal to 0, and we're going to solve now. In this case, I have already factored it earlier, so I have x plus 3x minus 3 is equal to 0, which means if I set each factor equal to 0, then I get two x-intercepts, one at -3, 0, and another one at +3, 0, right? So I have two x-intercepts, which I can go ahead and graph. All right, vertical asymptote. Well, to find my vertical asymptote, assuming that if I don't have a simplified version, just set the denominator equal to 0. All right, so we're going to set, this was for my x-intercept. This is for my vertical asymptote. All right, what I'm going to do with that is I'm just going to set this equal to 0, which is going to give me x is equal to -2. So there's my vertical asymptote. For my horizontal asymptote, then I have, let's see, I have to use that method, right? So I just have to see, when we talk about the degree, we're talking about this power. Which power is bigger? Let me zoom in so you can see it. The top power or the bottom power? You can see the top power is bigger, right? So because the top power is bigger, then that means it's bigger on top. The degree of the top is bigger. And if the degree of the top is bigger, as you can see from the horizontal asymptote rules, then we have BO2, which means I don't have a horizontal asymptote. So I can write over here BO2, and U stands for undefined, which you'll find out in pre-cal what that means. Basically, that means you could have a slanted asymptote. Right, my domain, as far as I know here, is going to be x cannot be equal to -2. And my range is going to be, well, all real numbers because there's no breaks there. Right, and really, guys, at this point, I would really encourage you to just use the calculator to graph the rest. Notice that I'm able to find all of this information without graphing, okay? And at that point, use your graphing calculator if you have it. If you don't have one, don't worry about it for now. The important part is basically how do you find the x-intercept, horizontal, vertical asymptote, etc. Right? I will at least graph or draw a vertical line where my my vertical asymptote is located, so I don't have to accidentally go through it. So if you look at your calculator, if you plug in x squared minus 9 over x plus 2, this is what this is going to look like, okay? Now notice that the only thing that I'm doing for you is I do have to go through those points, okay? So now that's it for that one, right? Let's go to example number 2, which is the last one, right? So I'll try to do this one quicker, and I'll probably by this time either you have stopped listening, if you're even listening to this, and or you're rolling your eyes and you're hoping I'm done quick. All right. Okay, so let's factor this to see if there are any holes here. The bottom part is a difference of squares, okay? So remember, go back to the factoring stuff if you don't know how to do this. Now notice that on this one, I do have a factor that it's going to cancel. All right, so those are the common factors that are going to cancel. All right, so now what does that mean? Well, what that means is that the whole is going to be located whatever thing you cancel, which in this case is x plus 1. You're going to set that equal to 0, and then you're going to solve. So you're going to get a negative 1. Now, to find the y coordinate, okay, let me erase this for a second. Well, yeah, let me erase this for a second. So the simplified version of this now, the simplified version of this would be x minus 5 over x minus 1. Okay. Now for the whole, this is basically exactly what I wrote earlier, which is x plus 1 is equal to 0, which means that x is equal to negative 1. And now to find the y coordinate of that whole, you're going to have to plug this into the simplified version, which is the equation you see in blue, right? So, make that smaller. So we have, let's see, right, y coordinate can be found like this. Negative 1 minus 5 over negative 1 minus 1. So this is going to be negative 6 over negative 2, which is going to be positive 3. All right, so why did I do that much work? Well, mainly because I told you to do so, right? But now I actually know where the whole is. Now, if you look at your calculator, the graph of this, you're not going to be able to see it at all. All right, so there's a break in the graph right there. Right now, the x-intercept and everything else is going to be exactly what I told you earlier. All right, but I'm going to be working with the simplified version of that, which is that. So now the x-intercept is going to be the numerator setting that equal to 0, which is x is equal to 5. So my x-intercept is going to be 5, 0. Let's see, vertical asymptote. Set the simplified version of this equal to 0, which is x minus 1 is equal to 0. So this is x is equal to 1. Okay. Of which I can actually already draw if I want to, right? So I have 1. Okay, now my horizontal asymptote, I have to see which degree is bigger, top or bottom. Now, in this case, you can work with the simplified version. Notice that the power here is 1, the power 1 here is 1, so they're the same, says Betsy. So I'm going to do the ratio of the coefficients, which that means the coefficient of x, in this case, is 1. The coefficient of x is also 1. Now, not to be confused, when I say coefficient, I'm talking about the number that's attached to the x. I'm talking about that 1, okay? Not the power. So in this case, the horizontal asymptote is y is equal to 1. So there's my horizontal asymptote now. All right. Okay, so my domain. Now my domain, you have to be careful. My domain is going to be x cannot be equal to the x coordinate. It cannot be equal to the x coordinate right there of the whole. And also it cannot be equal to the vertical asymptote, which is right there. Okay, so you have to just be careful with that. Now the horizontal asymptote, well, y cannot be equal to also the horizontal asymptote, which is 1. And also it cannot be equal to the y coordinate of the whole, which is that one. Okay, so it cannot be equal to either one of those. Okay, well, that's pretty much it. I know that was a lot of information, but I was sort of trying to make sure you understand the difference between the two, right? Again, as always, if you have any questions, just please contact me. Oh, gosh, Twitter page somehow. My apologies.